This video is about chi-squared GOF test. Goodness of fit. It's a measure of how well a statistical model fits a set of observations. For HO, it's always the data fits the certain distribution. H1 is the data doesn't fit a certain distribution. Make sure your expected frequency is greater than or equal to 5. Otherwise, you need to regroup the data. And also for this chi-squared GOF test, for HO level students, you need to pay more attention to the degree of freedom. It's not the number of data minus 1. You need to minus the number of estimated parameters. Then you will enter the data into spreadsheet to figure out p-value or chi-squared value. For chi-squared test, it's always right-tailed. In other words, when chi-square greater than critical value, reject HO. When chi-square less than critical value, fail to reject HO. In chi-squared test, make sure expect the frequency greater than equal to 5. Otherwise, you need to regroup the data. For example, this expected frequency is 4.7. So we will regroup this table. Observed frequency will be 16. 8 plus 5 is 13. Here, expected value 16.8 is good. 7.2 plus 4.7 is 11.9. Degrees of freedom. In SL level, it's always simple cases. For R data, degree of freedom equals R minus 1. If the parameters are estimated from the sample, the degree of freedom will be changed. For example, binomial distribution. We don't know this probability of success. We need to estimate this P from the sample. Then your degree of freedom equals R minus 1, then minus 1, because we estimated this parameter P. For Poisson distribution, we estimated this mean from the sample, then df equals R minus 1 minus 1 equals R minus 2. For normal distribution, if you estimated only mean, then your degree of freedom equals R minus 1 minus 1 equals R minus 2. If you only estimated this standard deviation sigma from the sample, your degree of freedom equals R minus 1 minus 1 equals R minus 2. But if you estimated both from the sample, then your degree of freedom equals R minus 1 minus 2 equals R minus 3.